Hello, everybody, and thank you for attending WELL's first webinar of 2024. We're glad to have you with us. My name is Megan Nessius, and I'm just going to be going over a few housekeeping items before I hand it off to our presenters. First of all, this is thanks for joining us on Teams. If you have any questions during the presentation, you can go ahead and use the Q&A button to ask them. You can ask them at any time during the presentation, but they will all be answered at the end of the presentation during our Q&A session. So yeah, go ahead and use that and we will get to your questions at the end. And then my next one is our AIA best practice information. So WELLS is a registered provider with the American Institute of Architects Continuing Education System, and our presentation is accredited through AIA. So if you are an AIA member and you were provided your AIA number to us when you registered, your certificate of completion, your certification of your attendance will be logged directly through AIA's dashboard online, so you shouldn't need a certificate of completion because it's automatic. If you're not an AIA member, but you would still like to get credit for this course, you can go ahead and email me and I will get you a certificate of completion within 10 days of your request. So I will have my email dropped in the chat for you guys, and it will also be on the very last slide during our Q&A session, so you should have plenty of time to write that down. So there are a few rules and regulations that WELLS must follow as a registered provider through AIA. It mostly includes the length of the program and the length of your attendance, but if you need a full version of those rules, they are easily found on AIA's website. So once again, thank you for joining us today, and I'm going to hand it off to Kurt.
All right, thank you, Megan. Welcome everyone to today's webinar. We're going to talk a little bit about prefabrication and how it's supporting the civic and community building development. First off, I want to introduce your two presenters today. Both myself and Chase Radu will be sharing components of today's topics. So Chase, why don't you start us off with a quick little introduction about yourself?
Hi everyone, Chase Radu, Director of Engineering out in our Brighton, Colorado location. I've been with WELLS going on about 9 years now, started out in the field and I've been kind of on the design engineering side for the last 7 or so.
Okay, yeah, my name's Kurt Gear. I'm business development in the state of Iowa, as well as an account manager. I've been with WELLS since 2013. I've been in the precast industry for just about 20 years now, and have been focused on pre-construction design assistance with the AEC community for basically the entirety of my career. So before we get into the main topic of our presentation today, I wanted to share with you just a little bit about WELLS. WELLS started as a structural precaster with just 25 employees in small little Wells, Minnesota, and we have grown into a full-line prefabrication partner and expanded our geographic reach. You see, we cover basically the entire upper central United States, Montana all the way to Illinois. Our team of talented members support the entire building process from the pre-construction and design assist phase all the way through installation. At WELLS, we believe the value of relationships and client experience is the key to our business. Including offices, WELLS has over 12 locations across the United States. All of our manufacturing locations that produce architectural precast are currently PCI AA certified plants. WELLS is a leader in the industry, serving 14 states with almost 1 million square foot of facilities on over 570 acres. As you can see here, these are our core values, and we believe they are important in establishing how our team works with our partners. We're safe, we're driven, we're inventive, and we're collaborative. WELLS excels at having the right people available at the beginning stage of your project to help develop the right solution. WELLS believes in providing value at all parts of the building process. As WELLS has grown, we have added additional prefabricated products and services, from in-house installation to a sealants and restoration department, to better support our partner needs. And today, we're going to be focusing on the civic and community market sector. However, we provide prefabrication solutions for virtually every market type. WELLS understands the unique drivers and needs of each of the market types that we work with, and our pre-construction team of sales, drafting, and engineering provide value-added recommendations during the design and construction process. Pre-construction is the area where we provide pivotal value to our partners and their projects in each of the areas listed. Many times these projects are hard bid, and we know as such that not something that Wells can know we are ultimately going to be a part of the team on. Price drives award. However, we still provide the full suite of design construction assistance for this market sector. Precast concrete is no longer just a standard gray warehouse panel. With combination finishes and new techniques in finishing have become the norm. By using custom forms, form liners, mixes, different finishes, and staining, we're now able to create or emulate almost any building material on the market. To see a full line of the Wells unique finish options, you can feel free to dig into our architectural inspiration guide on our website. And something that many of our partners do not know is that Wells has over 60 employees dedicated to the sealants and restoration division. This team covers our entire geographic region. They support not only new construction, but also do extensive maintenance and restoration work in the precast and other parts of the building systems as well. So now we're going to get to the focus of today's presentation. We are going to attempt to answer the question of how does precast as a building solution with its inherent characteristics lend itself so well to projects in the civic and community market sector. As you are aware, the civic and community market sector is far-reaching. We touch everything from community centers to water treatment facilities, and many of these projects are going to be serving more than one end user type, sometimes within the same facility. As such, many of these projects require very specific needs assessments completed prior to developing programming for the proposed space. In my 20 years or so in the industry, it seems as if 100% of the civic and community projects are controlled by a budget. So what can be done to achieve the best looking and performing building while staying within a budget? And the easy answer is that designers can and need to involve their local precasters for these aspects of the project. We need to collaborate to solve that riddle. And by the end of this presentation, we hope that you have a better understanding of how using precast and early collaboration can help you be more successful for your owner over the lifespan of the building. Now, Chase is going to kick us off today as he shares some of the aspects of project cost and schedule impacts.
Thanks, Kurt. So as Kurt said, pretty much all these projects are budget driven, budget conscious. You're using taxpayer dollars and trying to get the best bang for your buck. So, where can precast still play a role in that? And, a big one that often gets overlooked cost-wise that can contribute to that is the schedule. So obviously precast is going to be very schedule advantageous from, how it's a prefabricated system and it's got a weather resilient schedule. So where, other building materials as they're getting installed on site, especially in, a lot of the markets that we work in with winter, as long as it is, can cause delays where precast is going to be being made off-site in the plant, stored in our storage yards, while the footings and all the earthwork and everything is going on site, so that once the site is ready, it's being shipped and, we're just placing everything, welding it all together. So really weather does not hinder us a whole lot in the install of the building itself. That lends to a lot of predictability for scheduling and, kind of those end dates. Often the buildings are working in, if you're thinking community centers or schools or anything like that, we're going to have a hard open date that needs to be hit for those end users to get into and occupy the space. Other one is, quicker ROI, return on investment. Again, those bonds and taxpayer dollars, the sooner they can be put to work for those taxpayers, you're going to have a happier community and happier stakeholders. And then kind of where the schedule comes back into cost is, the cost savings from an overall construction schedule. There's going to be some, call it on-scene costs that, precast, maybe it's more expensive as initial building material, square foot to square foot against others. Once you factor in that month or 2 month or even 3 month, depending on the project size and scale, schedule savings that precast has, and all those other related construction costs that kind of go away with the building being completed sooner, can have a huge impact on the project cost overall. So related to this is also scope and risk. This is hard to put a dollar amount to, but simplifying scope and simplifying risk management is going to lead to more, lower dollar amount overall over the life of a project. With precast, you're going to have less trades on site. You're going to have simpler details to accomplish, depending on all the other materials that you're interfacing with. Something we see pretty common, like in the picture on the right, is precast panels with a steel structure inside. Those details are pretty tried and true. The coordination is pretty straightforward and pretty simple. With that, you're gonna, your risk for any scope gaps or anything like that is going to be reduced, which can be, unforeseen costs that pop up later on in a project. Envelope continuity is a big one that we'll kind of hit on a few times here with precast throughout. It's especially with sandwich panels, insulated panels, very simplified with the envelope for the precast all being in one piece, and then also being load bearing at the same time. You don't really have to penetrate that envelope or anything like that. And again, that's kind of down the road of moisture intrusion, air condensation, anything like that. With precast, you don't have that concern with your envelope causing maintenance or cost items down the road, or even during construction for that matter. Then the effort spent on contracting and buying trades out. It's more and more scope you can put into one contractor. It just simplifies that scope matching and scope gapping across the whole project. And then a big one we're seeing drive a lot of our markets, depending on the exact materiality selected for the design of the building, is prefabrication in general is going to mean less skilled labor demand. And then especially, we'll see in some of the project examples we'll go through later, if we're trying to emulate like a brick or anything like that, kind of stone cornice work, we can, we're seeing that we can be much more competitive on the precast side versus traditional hand laid masonry, just because that skill is, short supply and can be a high demand. So that cost seems to be creeping up. So another one that's often overlooked on the construction side for precast is how insurance assesses the risk of the type of material you're building with. Now, I think we've kind of all seen the issues, like in wood construction specifically, how vulnerable those buildings are during construction for fires, and how, if there is an issue that starts, how difficult that can be to contain. But there's also, a lot of other layers of that this is from kind of some insurance folks, of just how they assess the type of construction. So you can see here you have type 1 through 5, type 1 being the most attractive and type 5 being the least attractive. Precast or concrete in general falls up in that type 1, where its concrete is naturally fire resistant. It doesn't take any other special treatment applied to it. So even during construction, whereas steel's going up, there is vulnerable for a point until it gets its fireproofing on to get that rating. And this kind of correlates to, our next slide breaks down some graphs of what that cost correlates to for construction insurance. So if you're using a type 1 material, you're going to get a more favorable insurance rate during the life cycle of that construction. So you can see here, they ran two different scenarios. Study 1 is a 4-story mass timber versus a concrete masonry building. So over 4 million, they saved by, the concrete building would have saved just south of $130,000 over that, which I think equated out to about 8% or 0.8%. And then study 2 was 120 million concrete masonry versus a mass timber. And by using concrete, they would have saved about $840,000, which I think worked out to 0.7%. So round numbers there, you're just south of 1% of total project cost in the construction insurance right there by the type of building material you use. So other costs, kind of getting into the hard costs now. Initial construction, obviously, we recognize that precast is a premium material, so often if you're going square foot to square foot, it's going to be a premium cost. But like all those items we just mentioned have to be taken into account to really give precast a fair shake of what is it really impacting your project overall. The predictability from the schedule, the means and methods of how you have to protect that building overall. That's the beauty about precast is we can come in, set this up like you see in the picture, brace it. That's going to be an engineer bracing plan that's usually going to be covered under the precaster scope of whoever they're having install it. And you don't have to do any kind of tarping or heating, or and you might have some heating to do for the grout underneath of the panels during the winter conditions. But all in all, it's a pretty simple and straightforward and speedy construction that can help outweigh that initial cost. And where precast really makes stuff that isn't often considered or can't be considered in civic and community buildings is, at least for the initial construction cost, is the maintenance and life cycle of the buildings that we're building. So often you're seeing a 50-year life cycle. Precast has been around for 75 plus years at this point. We're seeing a lot of the original buildings still up, still standing, still going strong, with really only kind of that caulking and other minimal annual maintenance or semi-annual maintenance, at least inspections, if not, a 10-year maintenance cycle on the caulking or whatever is recommended by the supplier. So the, initial construction might be a little bit higher, but the life cycle tails off based on how long you can use the building, and the minimal maintenance that you have to put into keeping it up to be a, decent, usable building. Another big one here, especially, as we look into sustainability and how can we build resiliently so that we don't have to rebuild buildings, as we have natural disaster events occur or want to change the use in them, is, the resiliency of precast. Something we really pride ourselves on as an industry. It's a very robust material inherently. So you can kind of see this picture is from the Warren Theater in Moore, Oklahoma, I believe. We're going to touch more on this one specifically a little bit later, but it's just a good depiction of that's a precast building, obviously interfacing with some other materials. You'll see, tornado went through not too far away from this building. You can see contrasting between the precast materials on the facade and then the other materials, how well the precast held up. And really, never want to, we design and plan for these events, but if they unfortunately do occur, how quickly can the community get back on its feet, and what kind of efforts or money have to be put into rebuilding. And if we build right the initial time, that can really help that process down the line. With that, I'm going to hand it back over to Kurt. Well, he'll go over some design features and resources.
Yeah, what we'll talk about now is the incredibly versatile design features that precast has, and the availability of the design assist resources are the key attributes really that can help with these types of projects. When we're evaluating a civic and community project, we can work backwards from an overall project budget to understand what different aesthetic options we can explore based on what kind of monies are available for the skin. If we're looking at the space in regards to it being a storm shelter, we can also start to look at the impacts to the roof structure, the type of material we use both on the roof and the walls, and the overall size and cost of the exterior walls. One of the greatest aspects of precast is just its ability to give a significant amount of aesthetic versatility. You're seeing in the images here everything from a travertine mimic to sandblast, water wash or exposed aggregate, acid etching, which is creates a very clean cast stone type sugar cube look, and then combination finishes with thin bricks and stones and a combination of any of these. We have the ability to mix and match the finishes for materiality just to create the desired look. Now, with anything, there are cost and production limitations, so it's always best to involve your local precaster for any region-specific aspects to these architectural options, and they can direct you to a solution that will allow you to stay within your budget constraints. We'll start off talking a little bit about Formliner, from simple ribbed patterns to intricate designs like mascots and logos. Formliner suppliers can work directly with the design team to come up with the desired look. Some of these logo type images can be done internally as well with our CNC machines. You can create these logos out of wood or plastic and cast them into the panel. We can do multiple patterns within the same panel. You can have 2 or 3 different types of form liner finishes. You can integrate the form liner also with thin brick or other finishes. There are some limitations in regards to the form liner materials overall sizes. Generally, they're 4 foot wide by 12 to 15 foot long. So if you need to go with, you know, a full 30-foot panel where you're looking to have a continuous liner on it, you have to look at the idea of introducing horizontal reveals to be able to break the liner, because most of these patterns, the material can't be seamed together vertically without there being obvious seam lines that just aren't that attractive in a finished product. So there are aspects of form liner that have some intricate details, again, where if you involve your local precaster, they can help you kind of understand how liner is to be used appropriately and effectively within precast. Obviously, cast in thin brick is becoming a very popular option. In about the last 15 to 20 years, you've seen it go from masonry was very common, but with the shortage of labor and skilled tradesmen, you're seeing the idea of using thin brick and precast becoming more and more prominent because of the prefabrication component to it. We don't need laborers on the field. And as importantly, you know, these panels show up full of thin brick and they can be set in, you know, 10 to 12 panels a day. So you can have a building go up in a week or 2 versus if you had standard masonry, it'd be taking 2 to 3 months. Thin brick is something that we get shipped to us directly from the manufacturer. We have liners that we place in the bed. We're able to provide soldier courses, corner bricks, edge caps, basically everything you would see so that a finished building would have a similar look and feel to a standard laid masonry would. I would tell you to look for a brick that conforms to PCI tolerances. There are other tolerance thin brick manufacturers out there. TBX and TBS are the other 2. But in regards to using it within precast, we almost always prefer to look at PCI tolerance brick because it has tolerances of +0 in both directions and -1/16. It allows us to fit that thin brick properly into the liner and minimize the amount of bleed through that happens from the concrete onto the face of the brick as we're pouring and producing the panels. Polishing is a fairly new finish option. It's something that's been kind of developed over the last 3 to 5 years. This is a post-production finish. It's very common to be done on signage. It is a time-consuming and costly finish option. So we generally look at the idea of using this for an accent area or sign panels versus, you know, putting across the entire panel that's 10 foot wide, 12 foot wide by 30 foot tall. It's a very labor intensive. It's a slow process and it adds a lot of cost to the panel. So again, if budget is critical, which it is in most of these civic and community projects, the idea of looking at this polished finish to be an accent area or on signage panels or other kind of high visibility aspects of your building is a good way to use this finish without blowing your budget up. Reveal patterns, this is something that's been around forever, but we seem to be getting more and more complex. And kind of the sky's the limit with reveals. You see a few images here of some things that were done with some angles and some complex keystone looking elements and a combination of geometric shapes where we're changing the finishes within those areas. You know, reveals are something that can be done where they're a plastic material that's cast into the bed for each pour. Or we also, if there's a nice repeatability to it, like the image on the bottom in the center, if you can create a very intricate pattern, but it's something that's repeatable, we'll actually coat those reveals and that material down into the bed so that we can pour multiple times on the same finish. And that does help with the costs of the initial setup and everything that goes into casting those reveals into the bed. Exposed finish, this is probably the most common ones you're seeing out there. There's sandblast, which you see everything from a very light sandblast all the way to a very, very heavy. Acid etching is also very common. It's a a finish that mimics the look of cast stone. It creates a very, very clean, smooth finish. A lot of times you're exposing only your sands and your other fine aggregates. Water wash is also one that we use, and it is where we use a chemical retarder painted on the bed prior to pouring, and that chemical will actually keep the surface of the concrete from curing. Sometimes it's about an 1/8 inch or 3/16 of an inch of that outer white of concrete that will not cure. So the next day when the panel's pulled out of the bed, they can simply hit it with a pressure washer, and it will expose that coarse and fine aggregate that has cured into the concrete. And then it gives it a very rough look, but it also does a great job of exposing your aggregate. So if you're going to spend money on some granite or some other really nice river aggregates or something where you really want to expose those beautiful aggregates, that water wash finish is really the direction to go. And again, you can do combinations of these even within the same panel. As you see in that kind of that 3-sided mock-up there at the bottom, we can do 3 finishes all in the same panel. Micro etch printing is something that has also started to gain some traction. You've probably heard of it referred to as graphic concrete or Artico Neo, which is basically the name brands of 2 different manufacturers of these papers. It's a really neat process in which these manufacturers will actually print almost like a dot matrix printer would, that chemical, that same type of chemical retarder that we use, but they'll print it onto paper, and sky's the limit as far as what you can do from an image standpoint. And the trick is to this to make sure that your mix design that you use has a very stark contrast between your cement paste and, most importantly, your fine aggregates, so your sands. So what you're seeing on the 2 images here on the left is something that's 100% white cement for the cement paste, but then the sands are a very, very dark, probably like a UC Mason black sand, so that when you expose that sand with a water washing or pressure washing finish, it gives you a very, very stark contrast. Where you would not want to be using something like this is if you had buff cement and you were using tan or buff aggregates. It would just be very, very difficult to see enough of a contrast between the two. And again, working with your local precaster to decide if there's an area of your building, whether it's the signage or the main entrance, or maybe it's the entire building as a whole, where you can evaluate these. As you can imagine, there is a cost associated with this paper, and depending on the complexity of the print and the size or area of the panels that you're wanting to use this type of micro etching on, it can have a significant impact on what kind of cost it is to your project. Now I'm going to turn it over to Chase here for a little bit to let him talk about a few of our key projects that we've done here in the last 3 to 5 years or so.
Thanks, Kurt. So like Kurt was just talking about, that micro etch, this is a community center up in Forest County, Wisconsin, northern Wisconsin, that is a great example of that micro etch graphic paper, and also kind of engaging your precaster early to kind of solve that riddle that Kurt referred to early on. So this is a building that, you can see the pattern there on the lower part of the panels, that they wanted to emulate kind of the pattern that's on eagle feathers, because it's a very, important symbol up in that part of the state. And so, working with the precaster and engaging, we were able to kind of help them do a very cost-effective solution, less than what they were planning on, because that's all one concrete mix there. So like Kurt was talking about, where you kind of play with turn the dials on your sands and your cement paste and everything like that. You can, get these color variations that make that pattern pop while only using one mix, which is much more cost effective than trying to mix and match different colors within the same panel. Next one here, another very unique building here that was, kind of a renovation where we did some precast thin brick, integrated with original hand laid stone, some other materials on this building, and that's specific custom arch over the new entrance that you see in that upper left picture. That's towards the right of that picture. Just a great example of, again, when you get engage a precaster early on, let them work with the design team. This took multiple site visits to kind of talk about how the transitions are going to play out, what they interface like, and what the different materials were going to look like. Bringing samples out to site and kind of putting them up against the actual building that was already there. That turned it into a very cool and unique project in Minneapolis, Minnesota. Broomfield Rec Center. So this is kind of classic example of how total precast can solve a lot of issues on this rec center. So you can see in the upper two right pictures, gym and pool both have a precast double T roof over them. So that's something that I think a lot of folks don't realize the advancements precast has made is we can do spans over 100 feet, 100 feet plus. On this project specifically, we had a 107-foot double T span to kind of get that clear span over those large open spaces, and that's a equatable depth to what would traditionally be a steel member, around that 42 inches mark. Then the rest of the building was a lot of precast wrapped around the building with different textures and materials and colors. Brick, and then even one elevation kind of had a ribbed sawtooth pattern. It wasn't in the same plane to allow a lot of light into that pool because it was in a, kind of the side of the building where there wasn't a lot of natural light. So again, engaging early on with your precasters, let us be part of the solution to solve whatever hurdles you're up against that come up on challenges. Austin Community Center in Austin, Minnesota, very sharp looking building. Again, kind of a modern twist on a kind of traditional brick design that's, a lot of ins and outs, a lot of undulations. So making sure everything transitioned correctly with the steel structure inside and everything. Again, that coordination and envelope and scope was covered. A lot of time went into this design early on, kind of on curbside with the pre-con folks from Wells to help this project come to life in within budget or under budget. Lake Elmo Fire Station has gone, this one's pretty unique in that when Lake Elmo was looking to update their fire station and their community center, they decided to build it together. So you can see in that bottom left there, you got kind of the fire station on the left side and then the community center on the right, or the city center on the right. But fire station was an ICC 500 storm shelter. So that's, Kurt's gonna go into that a little bit more in detail later, but basically it's a hardened shelter for tornadoes. So it's a new part of the code. As code gets updated and adopted, it's part of ICC, and we're seeing it more and more. They got specific zones and maps that will show, but really what those are there is to withstand those natural disasters, specifically tornadoes, and be kind of a refuge for the community that's going to be there. That can get back up on their feet. So we're seeing them a lot in schools, seeing them in community centers. This one was done on the fire station just because it was the first building they were building with the new code that had to adhere to it. So, but again, this is kind of a unique facade that where, those dark elements or those really dark elements are still precast. They're there to kind of mimic charred wood. That was, the architect's vision and design. And so they got with the precaster of, can we even do this out of precast? Or are we going to have to go look at a wood material that's going to be, probably much more expensive and a lot more maintenance intense down the road? And we were able to figure something out that mimicked that, emulated it, and still provided all the benefits of precast of being load bearing, envelope, minimal maintenance, and all that. Jackson Fire Station, it's personally one of my favorite buildings. I just think it's very cool with all the different features. Again, what might have traditionally been out of masonry, but for whatever reason, skilled labor, masons, availability, cost, went the precast route, but still put in the cast in thin brick. Did a lot of kind of stone bands that you're seeing, the stone arches over the doors, cornice work, all that stuff up and around the town, or up around the top of the building, and led to a very sharp looking building for this community, and also one that's going to be very robust and stand for 100 years if it's maintained right, to service this small town in southwest Minnesota. Then the Williams County Jail out in North Dakota. This is a total precast facade, and it had a lot of interior walls too to make up the jail cells and everything like that. But this one was big on they didn't want it. This was kind of when North Dakota was going through the boom, and they didn't want it to look like a jail. Traditionally, you see the fencing and the gray, and it's pretty telltale. They wanted at least the kind of admin back of house side to look like another building in the community, and be a little bit more welcoming to the folks that were visiting there. So worked with a design team, figure out, a good cost effective, fairly simple precast facade, a lot of repetition there, which is the name of the game with precast. The sandblast and acid etch to kind of create some variation in depth and texture like Kurt was talking about. And then a lot of precast in the interior just to provide those security walls, the secure spaces and everything like that you traditionally have with HAL. So just to touch on natatoriums and aquatic centers specifically, kind of like I mentioned with Broomfield, a lot of folks might not know that we can do those spans with the double T roof structure, and we're seeing that more and more in natatoriums. Obviously with the ambient air moisture and chlorine, everything like that, steel roofs can start to cause some problems down the road. And so, precast double T roof, you get that nice durable concrete surface. And then also, we're going to detail it in a manner that isn't too cost or doesn't add too much cost, but is really going to minimize even the steel connections that we do have between the precast are often going to be stainless. So they're going to be, minimal maintenance for any moisture that they do see also. Getting into functionality and resilience here. So this is, a section where if you start with precast in mind on the design side, the building can benefit from that when you module right. For precast modules and typical spans, if we're trying to start with a what might have been a steel structure and then kind of put in precast at those grids and spacings, often that's not going to be too cost effective for the precast. If you start out with precast modules, you'll see a lot of just natural cost savings from efficiencies on the precast side, specifically for functionality, like I was talking about and showing. I mean, we can do large open spaces, and no columns like in the picture on the right. But folks need to know that we can do that, and they need to reach out to their precasters to see what your local precasters have the ability to do for specific spans and everything like that. Efficient framing options, beams, columns, double T's, that's something we see pretty often where, maybe we try to do precast walls with the steel structure inside or some CMU walls. The more precast we can do, that's going to where that schedule impact comes into play, is, let the precaster get in and set all that precast at once and move out. You're not trying to work around other trades. You're trying to provide access for anybody else in. And then just the general framing options of the loads, material, pre-stress can be very robust, can hold, 250 plus live loads pretty easily, pretty commonly. So specifically, Minneapolis Bus Garage here, this is another project that, a little bit of a case study is a great example of how that precast, designing with it, really lended itself to a functional building that was otherwise going to have some issues. So this building is in Minneapolis, Minnesota. I believe it's named now as the Haywood Bus Garage, but it's for the Transit Authority up there. Their new electric bus fleet, they needed a new building for almost, I think it's 300 plus buses or so. But just the site that they had for it didn't lend itself to the buses being able to come in on, call it kind of grade level for where the site was. So they were looking at either having to fill up massively for the buses to come off the adjacent streets and be able to get into the site, or what they ended up doing was doing a multi-level structure and doing employee parking and everything on the slab on grade, since it was easier for the cars to kind of spiral down and get there, and then having the buses actually drive up onto the mezzanine, which seems a little counterintuitive. And that's this was the operations and maintenance center and overnight parking for all these buses. So you can see in the two pictures on the right, those pits, those wash pits and those jacks, they're all sitting on a precast mezzanine. And then that picture on the bottom left is of that precast mezzanine, then with the precast roof over top. And you can see, even with the bus loads that we had for AASHTO and everything like that, we were able to, keep a pretty wide open space so those buses could, move pretty freely and not have to worry about how many columns they had to dodge as they try to navigate through this, pretty large facility. So then I'll hand it back over to Kurt to cover some other items in resilience.
Yeah, sure. Okay, so let's talk a little bit about resilience. Obviously, we know that concrete is a durable surface. It's a maintenance-free finish. You can use the interior exposed walls in almost any gym space, community center, public works. A lot of times they're painted, but for the most part, that's about it. And with the integral nature of color and finish at the exterior of the walls, it provides that cleanable and essentially maintenance-free finish for the skin of your building. The one consideration you want to think about there is in regards to where your sidewalks are or your drivables, the idea of obviously salt being used in most climates where you've got snow and ice conditions. The finishes that you want to look at for those lower areas where there might be interaction with salts and other winter type additives are something that has less exposure. So like an acid etch finish or even a polished finish is going to do very well being resistant against those salts and other things that are kind of hand applied in those areas. When you have a larger, more exposed finish like a water wash or a heavy sandblast, there's a more impactful deterioration that can happen if there's continuous salts used year after year after year on sidewalks or drive lanes or whatever that abut right next to your precast finishes. So just think about that stuff as far as what finishes you have interact with your other concrete surfaces where you might be using salts and other things like that. And one of the hot topics these days is the implementation and use of these ICC 500, storm shelters and the requirements that are needed in these shelters, throughout the heartland of the U.S. As you can see by this chart here, there has been tremendous cost impacts from storm events over the last 44 years, and this has just been documented from 1980 to 2024, National Centers for Environmental Information. And you can see how that Minnesota, Iowa, Missouri, Illinois area, and Texas and Colorado has had just significant cost impacts from storm events like this, total destructions of buildings, whether they be residential, commercial, or combination. It seems like the K-12 market and the civic and community market are the ones that are most active in this ICC 500 storm design due to the requirements that have been dictated now through updated building code requirements and whatnot. You can see that these IBC had to make some significant code changes to what and how to build in these regions. You can see the map there showing where that 250 mile an hour wind design needs to happen at. There are several civic and community building types that will fall under these storm shelter requirements. As you read, anything from schools to 911 centers, emergency ops centers, fire rescue ambulance buildings, police stations, all are going to be required moving forward to have some area within their buildings and new construction that have an area constructed in accordance with ICC 500. And precast and specifically pre-stressed concrete components have inherent advantages as a material in regards to their ability to help resist the incredible forces imparted on a structure during a 250 mile an hour type wind event. You're seeing here, concrete is a heavy material. Obviously, it's extremely hard. The missile impact requirements from ICC 500 are something that precast concrete and concrete in general can meet with only 3 to 4 inches of overall thickness. And the biggest attribute of our products that make these abilities to meet these stresses are the pre-stressing aspect. Yeah, we'll just discuss here in just a second about how the pre-stressing component is so impactful, both in walls and double T's here. When we talk about precast walls in regards to ICC 500 design, there are usually one major impact that needs to be accounted for, and that's your wind pressures. Obviously, there's both suction and pressure on that wall, and for the most part, a pretty standard walls, usually in that 12-inch thick area, and to go to an ICC 500 design, we've generally only had to increase the wall thickness by about 2 inches. Generally always in that structural width. That interior width generally grows from 6 to 8 inches, and that's just to handle the increased wind pressures that are going to be applied on that wall, as well as, you know, the roof material is usually going to switch to something like a double T, or at least a much more heavier roof section. And that's going to require that interior white to handle a little bit more load from transfer from the roof to the wall, as well as a little more self-weight to the wall. And that self-weight is something that's going to be beneficial, as primary load that you have to account for is uplift. The other thing that's been unique about precast and a change in the ICC 500 code is that the original ICC, I think 2013 code, talked about that joints had to be no larger than 3/8 of an inch, and if they were, they had to be protected, whether interior or exterior, by another material. And that 3/8 inch panel joint is just not something that works well in the precast world. You're seeing, for the most part, precast joints being designed around either 5/8 of an inch or 3/4 of an inch joint. And so there was a bunch of testing done by Texas Tech University, throwing gravels and other materials at joints that were 3/4 an inch, and essentially they created enough data, and it was presented to the ICC 500 committee, that the new code, the 2020 version of ICC 500, has an allowance in there for precast panels and concrete type structures to allow up to 3/4 of an inch of a joint. Now, not all city and state agencies have adopted IBC 2018, and I think that's the one that will bring into itself the ICC 500 2020. But once 2020 is fully accepted and fully implemented, you'll see that that requirement changes from 3/8 to 3/4 for all of your panel joints when using concrete. As I said earlier, when we're talking about these shelters, what always controls design is uplift. If you think about a large box, whether it's a gymnasium or a performing arts center or some kind of box, whether community center or otherwise, it's the roof that is going to be undergoing the greatest force that controls design. These buildings sometimes end up having uplift in the range of 250 to 280 pounds per square foot, or sometimes even more. And depending on the volume of the space inside of the shelter and the length of the span will help dictate, you know, what that overall design is. But that uplift being in that 250 plus number is not able to be canceled out just in the self weight. A double T might have a self weight of 80 to 90 pounds a square foot, and then if you put 4 to 6 inches of topping on it, you know, you might get to either 150 or 175, somewhere in that range of just dead weight of your roof material. Well, you're still 100 to 120 pounds per square foot away from meeting the design load that you're trying to resist. And that's where the idea of pre-stressing is so critical, because with these double T's or hollow core members, we actually have the ability to put some of that pre-stressing strand that's almost always in the bottom of a T-stem to create the upward camber, while we transition or add some additional strand at the top of the double T-stem, basically right below the flange. And what that does is it allows for some internal stressing resistance. So if a wind event were to hit that building, and as that upward suction were to be applied to that roof, that double T roof would deflect upward, but that pre-stressing strand at the top of the double T stem would work to resist as well. So even though we don't get there from a dead weight standpoint or self weight, we can handle the remainder of the uplift that has to be allowed through that deflection and transfer of those loads from the double T's to the walls, and then transfer through the walls into the footing, which almost always has to be increased in size as well. So just know that there's a lot of complexities to these ICC 500 shelters, whether you're talking about the entire building you're developing or putting an area within your building and having it be developed as your shelter. And again, working with your local precaster is going to allow you to understand what limitations there are, what cost considerations and materiality considerations you need to look at when you're trying to develop these shelters within your projects. And like Chase alluded to earlier, there was that one picture, and You know, thankfully and luckily, every ICC 500 shelter that has been built since 2008 has not been hit directly by an F5 yet. There are a lot of them standing now, and they're all designed, but so far we haven't had anything that's taken a direct impact. Nationwide, there hasn't been a single F5 tornado that has had any impact with an ICC 500 shelter that's been built. This is the closest thing to it, and you can see in that picture on the left that the center line of the track of that F5 tornado that hit Moore was just about 1/8 of a mile directly to the south of it. And the IMAX Theater here on the far right of that picture, again, none of this has a precast roof. This is all just insulated wall panels with a standard steel joist roof. But this building stood and had some damage to windows and other stuff, but for the most part, had very little structural damage, as one of the largest tornadoes in U.S. history went by it less than 1/8 of a mile away. Sorry. Now I'm going to turn it over to Chase here to kind of talk a little bit about our maintenance and expansion component of the CNC world.
Thanks, Kurt. So touch on maintenance and expansion a little bit, mainly maintenance on the cost side. So just want to get into a few of the specific items, that contributes to that low maintenance cost. So the big one for us is going to be, another code updates that's becoming much more stringent is continuous installation. Whatever system you're using, the code wants continuous installation to create that nice tight building to reduce energy consumption. While precast has naturally been for insulated panels, we want continuous installation. We don't like solid zones that cause condensation or other issues with our panels. So we're going to do edge to edge insulation. We might have wood nailers in or anything like that for window or roofing attachments or door attachments. But our envelope is going to be pretty tight, and we can do some special stuff too if there's typically don't see it on the civic and community side, but if there's any kind of coolers or freezers, there's some other vapor barrier special detailing we can integrate into our panels to farther increase that. And then generally just the comfort of precast buildings, concrete buildings in general is, with that insulation and then with the thermal mass of the structure, you don't get the high peak demands on your energy systems for cooling or heating that you might with other more porous or poorly insulated envelope systems. And then depending on what's going on the inside or the outside of the building, it's pretty easy to wash down the surface. If you leave the interior concrete surface, if you don't do any drywall or anything on the inside of it, which we see pretty commonly in these spaces, just so that it's nice and durable, like we talked about, spray it down if it gets mud or paint or something on it, and just get out the pressure washer hose, spray it down. Same with the outside. If you're getting kind of dust sticking or any salt or anything from sidewalks, stuff like that, sprinklers can pressure wash it down. And then really the only preventative maintenance we are going to recommend or see on our structures is the caulking at the joints. And then obviously if any windows or fenestrations you have, any caulking that's on those also is going to need to be addressed. And the service life, like we already talked about, is going to be, as long as you treat this building right and use it how it's supposed to, it's going to be there for 70+ years, like we're seeing with precast structures that have been up around. And even with that, as we get into the expansion here, if there is a change in use, it can usually be accommodated pretty easily. So it's, if you're going to swap out an RTU on the roof, or if you want to come back in and cut some more man doors or windows or anything like that, get a hold of that precaster if you can, the original precaster, or if you can't, then a precaster, and they can help kind of guide you in what openings would be acceptable for that building. Another big part of precast that's pretty slick is if there is a building that's planned for expansion, we can integrate that into the original design. And then when it comes time to put that building expansion on, you literally grab the original concrete precast pieces, cut them loose, go put them on the new spot on the addition, and then basically just kind of fill in the gaps of whatever the footprint is, you can see in the picture on the right there, that's exactly what they're doing. They've taken a couple panels off the corner and they're laying them down. And then they'll put them back up once they're gonna add on more pieces. And then also too, if there's any kind of loading changes, like kind of talked about RTUs, but if there's, bridge cranes that you need to upsize, if you had something attached to the bottom of the double T's, or if you want to mount something off the wall, a little jip crane, precast can usually accommodate that pretty easily. Referred to are usually like a 6-inch interior, so anchors, epoxy, anything like that is easily accommodated.
Okay, I'm going to take over now, and as we wrap up today's presentation, I just want to reiterate to you as members of the AEC community that what you can do to help make your project successful and creative as possible when working in the civic and community market sector. As we know, money drives these projects almost every time, so utilizing the expertise of your local precasters, design assist team members will be critical in moving the project toward the end goal of creating a building that meets and most likely exceeds your owner's expectations. The simple answer to when is the right time to involve your local precaster is simply the sooner the better. Precast is the right choice for keeping your projects cost-effective, beautiful, thermally superior, all while being built in an efficient and timely manner with a finished product that the owner will be able to enjoy for many years to come with minimal operating cost. And that concludes our presentation for today. And I'm going to turn it over to Megan here for the Q&A aspect.
Thanks, Kurt. So go ahead, and if you have any questions about the presentation today, you can use the Q&A button to send those in. While we wait for those questions come in, I would like to point out to everybody who's been attending WELL's webinars, if you by chance missed any of our previous ones, we do actually have 10 of our previous topics available for on demand. And these are eligible for 1 continuing education credit through AIA. So all you have to do is you can go to our website and find our webinars page, and these have a link to the video from our original webinar, and then you can watch the video, take the assessment, and then we gave you your credits. So check those out if you're interested in earning any more credits, or if you want to explore any of the other topics that we've covered in the past. So now I'm hoping we can get to our Q&A section. So we do have one question in so far. So do you just provide thicker tendon cover on double T's in pools to prevent corrosion, or do you use other techniques?
And take that one if you want to. So we don't provide anything thicker than what we typically do. Now, what we typically do does meet the cover requirements for pools. Often we're using our double T's in water treatment facilities and food processing facilities. That are that one's a little bit outside of the civic community. So we have a lot of environments that our double T's are being used in. Parking garages would be another one where we need to meet similar cover. So that's kind of just the natural cover we use on our pre-stressing cables into the stems of our double T's.
Thanks, Chase. It looks like that was maybe our only question that we have. Do you guys have any other insights into frequently asked questions about any of the things that you covered today that you want one last chance to let our viewers know?
I think just maybe to expand on what Chase said, a lot of times those natatoriums, they're looking at, putting some kind of elastomeric type coating on the underside of those T's as well. Obviously the concrete cover is your primary protector, but then that elastomeric coating that's usually post-applied is something that just helps keep that moisture and that caustic chlorinated type air away from the surface of the concrete as well.
Thanks, Kurt. We do have one more from Drew. What types of metals can be used in attachments to precast, such as aluminum, cold form steel, etc.?
Chase, you want to take that one too?
Yep, I can take that one. Yeah. So kind of any and all, really. I mean, it's got to be done right, obviously. So we see it pretty often where, hatch channel or drywall, stud is going right on the surface for our concrete. Now you will want, those materials are going to move differently. So that's going to want to be a slotted anchor location, and then like for aluminum or, IMP or kind of miss metals like that are maybe, an extra feature on the facade that are attaching to the precast. We can accommodate those too. Usually when it gets into like aluminum, the thing to watch out for is, welding compatibility. We're using mild, 836 generally for all our embeds in our panel, which I'm no welding specialist, but can, I think, cause some issues trying to weld aluminum too. So sometimes some of those got to be post installed or kind of an anchor driven one instead of a welded connection. But yeah, I mean, any other material, I think you probably saw in a lot of pictures throughout the presentation. We had wood, we had steel on the facade, all that type of stuff. That structural is pretty cut and dry. That's something we do a lot on the interior, but kind of those missed metals or any other stuff on the exterior can be done. It just has to be detailed and coordinated correctly.
All right, thanks so much, Chase. That is it for questions today, and we are at 12 o'clock. So I just want to thank everybody again for attending our first webinar of 2024. We hope you learned a lot. And then just a reminder that if you do need a certificate of completion to be sent to you, go ahead and shoot me an email, megan.nessius@wellsconcrete.com. Thanks, everybody, and have a good day.